interaction with deformable smartphones.
Hi. So today I'm talking about one-handed bend interactions with deformable smartphones. I'm Audrey Girouard. I did this work with my students Jessica Lowe, Riyadh Sharif, Farshad Daliri, Alex Eady, with the collaboration of Jerome Pasquero, who was at BlackBerry but now at Matsai. So we've seen this in the previous talk as well. Smartphones are becoming larger and larger, and this makes it difficult to do single-hand interaction because our thumb has a limited reach, and so it's hard to access everything that we have on our screen. So two easy solutions: we can regrip, or we can use two hands so that we can access the data. So there's been a lot of research to explore how to extend one-handed interactions in rigid devices, either through touch or through the use of pressure and buttons on the side of the device. So we think flexible displays offer an opportunity to address this. Right now, all of the work with flexible displays with deformable user interfaces have the participants use two hands to interact with the prototypes, either with one hand to hold the device and one hand to interact with it, like with paper phone or FlexView, or simply two hands to hold it so that you can deform the whole phone. So that's the Nokia prototype. Bendy, FlexPad are all examples of this. So we looked at how we can use one-handed gestures with flexible displays. So we started by looking at current common single-hand mobile interactions in rigid devices, and then we designed and evaluated a group of flexible gestures to accomplish this, all with the goal to offer the potential to address finger reach limitation in large smartphones. So we ran an online survey to investigate one-handed usage in current rigid smartphones, and about 87% of our participants indicated that they were right-handed, and that's important to note because that's reflective of the general population. So when we ask what hand do they typically use when they're doing one-handed task, 72% answered the right hand, 9% answered the left hand exclusively, and then about 19% answered that they use both hands equally, or they really don't have a preference for it. When we asked them in which locations, which scenarios do you typically use one-handed task, a lot answered while walking and while standing, and these two really represent mobile scenarios. That's where most of those tasks happen. In terms of what people use, what people actually do when they're only using one hand, we really find tasks that are either a single tap or a short swipe, as opposed to tasks that use a variety of gestures or gestures with multiple fingers. It's pretty hard to do a zoom, for example, as you know, with one hand while trying to hold the device. So what did we find with this survey? Well, we found that the majority of the users use the right hand to hold and interact with their device, but there's about a quarter of the population that either use the left hand exclusively or interchangeably. So that's something that's pretty important to look into. One-handed gestures are more common in mobile scenarios, and then they're typically used for either unique touch events or identical repeated events. So we use that data to design our gestures and our experiments. So we determine a large set of possible one-handed bend gestures using a mock-up prototype, and then we reduce this set based on dexterity, hand size, and ergonomic constraints. So we came up with 4 locations. So the top left corner, the top right corner, either a central squeeze, so squeezing the whole device, or just a bottom squeeze where only the second half of the device would be bent. And then we have two directions, either up, which we mean towards the user, so creating a convex shape, or down, which is away from the user. So we have 8 gestures total. We designed a prototype, a large smartphone prototype, which was about the same size as a Galaxy S4, because that was one of the questions in our survey. A lot of participants use large devices. We have a two-part mold that was designed so that we can have silicone on both sides, which makes a really comfortable device, because that's very important if you're going to hold it in your hand. We put the flexible circuit in the middle, and then we project it on the prototype. Here are examples of the 8 gestures. These are performed by a single participant, so to give you an idea of how they were holding our device. So we designed a study to investigate the accuracy of our one-handed deformable gestures. We wanted to know which ones were performed faster, which one had less errors, which one were preferred and more comfortable. So we designed 2 tasks. The first one was, we call the single task, was designed to mimic most of what the current actions are, which are, for example, answering a phone call or selecting an application. So this is what the users, the participants saw. Just do top right corner up, they do it, and then they have a confirmation that it was right. The second one was to imitate, for example, browsing pictures. So a repeated task where you're going to do next, next, next a few times. So this one, they were asked to do a gesture, in this case, top right corner up, but they had to do it 9 times, and every time they did it, a circle filled with green, and at the end, it was a completed task. So we ran a 2x2x4x2 factorial repeated measures within subject design. We tested for both hands. We tested the 2 types of tasks, so the single and the repeated task, our 4 gesture locations, and our 2 gesture directions. We had 18 participants, 15 of which were right-handed. We measured the duration of the gestures and the number of errors, as well as preference and comfort. So this is our results, the duration results for the single task. We ran an ANOVA and found that location has a significant effect on duration, mainly that the center squeeze is faster than all the other locations. And we found that the up direction is also faster. The interaction of location and direction was also significant, and what that revealed is that for the bottom squeeze, the up gesture is significantly faster, and as well for the top right corner, the up is faster than the down. So if we look at the same data set but categorized by hand, we found that hand by location is also significant. So what is interesting here is that we find that the top left corner is faster with the left hand, and the top right corner is faster with the right hand. So in our analysis, we based the location on simply the location of the gesture. So whether you performed a gesture with the right or the left hand, it was categorized as left. So we did a post hoc analysis categorizing the gestures by finger, whether they were done with the thumb or the index, and we found that to be significant. And so gestures that are performed by the thumb are faster. When we looked at the repeated tasks data, the first thing we noticed is that the first repetition follows closely the duration measured in the single task. So we assumed the analysis would be the same, and so we only looked at the repetition 2 to 9, and we ran the same analysis and found no significant factors or interaction in this case. So hand, gesture location, gesture direction do not contribute to the variability of the duration and the number of errors. We asked participants whether they found each gesture comfortable and whether they liked it. Our results are the same, so I'm just presenting a comfort. What this data shows is that the gesture that are more comfortable are the top right corner and the center squeeze, and that in general upward gestures are more comfortable. There was no hand preference that we found in terms of comfort, so people like to perform them with the left and the right hand. We also observed a certain number of things while we were running the experiment. The first of which is that directionality was problematic for the squeezes, both the central and the bottom squeeze. People didn't quite know how to perform it. If I say do an up squeeze, up center squeeze, they didn't know whether that meant that the middle of the device was supposed to go up or the size of the device that was supposed to go up. So there's sort of a disconnect there that would be important to keep in mind if you use those terms and you design gestures. Users also seem to have trouble separating the center and the bottom squeeze from each other. Sometimes they were trying to perform the other one and they were persisting even in spite of feedback that indicated that there was an error. So they really had trouble between those two. Many users had difficulty activating the corner opposite their thumb and were forced to change the grip, like this example with this participant. So in terms of grips, we did observe a certain number of things. The first thing is that users exhibited a variety of grips when it came to interacting with certain gestures. So some of the grips occluded the screen significantly. Some resulted in an unstable hold while regripping. Some users dropped the device because the grip wasn't successful. And really what we take from this is that many users voiced displeasure and frustration whenever they had to change the grip, and they really wanted to maintain the same grip throughout all the interactions. Hand size also influenced how people grip the device, and it's more in the extreme. So very small hands had difficulty reaching corners, while very large hands had difficulty controlling how they bent the corners. And finally, we ended up sort of observing whether participants occluded the screen while doing each gesture. And yes, we can see in this example that the top left down gesture is pretty occluded, but this is not necessarily how most participants perform this gesture. So in general, actually, we didn't observe occlusion to be a big problem with bend gestures, as we typically are used to with touch gesture. So what can we learn from all of this? Well, center squeeze is the fastest. It's very comfortable to perform. It's one of the two preferred gestures, and you don't need a special grip to do it. You can do it whether you're holding the device more towards the top or the bottom. Top gestures are performed by the thumb are faster and are the preferred ones. So if you do a top left gesture with your left hand, that's faster, and top right gesture with the right hand. So taking into account how somebody grips the device and which hand is currently active would be important when you're designing how you're mapping your gestures. Bottom squeeze, really not successful. It was slow, it was full of errors, participants did not like it at all. So we suggest simply merging it with central and having a single squeeze, although possibly a better sensor configuration could help distinguish the two better. A few other things that we notice: well, up is faster and preferred. There's really no sort of repositioning of the hand that's required because you can simply push your phone. In terms of hands, they're somewhat equivalent in terms of performance and preference, and that's really interesting because we can accommodate all the population, the 25% of the population that really likes to use their left hand. Well, they can, because here it's we get equivalent results. For the repeated task, we get that the repeated gestures are 3.6 times faster than the first gesture, which could mean that we can that we should map actions that are the same to the same action. So browsing a website, well, next should also be the same thing, but also that if we have different actions that come in a logical sequence, maybe we should map them to the same gesture. For example, if you open a camera and take a picture, these two things often go together. And that's the first thing that people want to do. Yes, there are other options, but if I'm going to take a picture, I could squeeze to open the app, and then I'll squeeze again to take a picture, and I'll squeeze again to take another picture. And so that way I don't have to regrip, and my picture is going to be taken a lot faster than if I had to change and figure out what other gesture I would need to do. So in this work, we explored one-handed deformable interactions for flexible smartphones. We did an online survey about one-handed habits in rigid phones. We designed 8 gestures and ran an experiment to evaluate those gestures. We found that the best gestures were the top right up and center squeeze up. That either hand can work. We learned that regripping is important, so designers should really try to minimize regripping as much as possible, and that occlusion doesn't seem to be a large problem in deformable gestures. So we think that one-handed gestures are interesting, they're complementary to touch, and they warrant more exploration. And just as a little plug-in at the end, we have an opening in our department for a new assistant professor. So if you're interested, let me know. And I'm always looking for new PhD students. So thank you. Any questions?
Hi. I'm Yuntao from Tsinghua University in China. Great talk. I have one question. Why choose these 4 positions, like left, top right, centroid, the phone, and the bottom? Why not use bottom left and bottom right? Because I can use my little finger and also the palm.
It's pretty hard. We tried, and we had a bunch of people in our lab try these positions, for example, and most people couldn't make them happen. And yes, the bottom finger, I thought I could perform the bottom squeeze pretty well, but clearly most people couldn't, and so we eliminated like individual corners because people just couldn't perform them beforehand.
Okay, so you did a survey before the experiment.
Well, we tried to generate as many gestures as we could, but then really based on different hand size and dexterity, we eliminated the ones that just performed horribly with the people within our lab, because we didn't think those could extend to the general population.
Okay, thank you.
Pleasure.
Hey, Giovanni from University of Copenhagen. Thank you for the presentation. Very nice. So I think besides compensating for the difficulties that we have with one-hand interaction, what do you think the gestures that you have shown could be used for when interacting with mobile device? With what kind of applications?
Well, I think they would be good at doing the sort of short interactions. So it could be responding to a notification or answering a phone call, and those types of very sort of one-click type of interactions. And so that's how I see them to be helpful, in addition to well, in combination with touch.
Okay, thank you.
Pleasure. Thank you.